its IUPAC name will be methenamine, just following the directions for writing the IUPAC. If I ask you the common name, so how will you write the common name? Common names are also very simple. Clear in your mind is this, that this group, that is C double bond ONH2, is what? It is amide, okay, and NH2 is what? It is amine, okay. So the very first question which arises is this: how do we name amines? Okay, IUPAC names for aliphatic amines are derived just as we have derived in the case of alcohols. So what happens? That the final E of the parent alkane, that means this E, is dropped and it is added to the amine. So that becomes our IUPAC nomenclature. Okay, and we have to indicate the location of amino group on the parent chain by a number. Location what you will write. So the very first compound in this is CH3NH2. So what will be its IUPAC name? Its IUPAC name will be methenamine, just following the directions for writing the IUPAC. If I ask you the common name, so how will you write the common name? Common names are also very simple, that you have to write the substituent as YL and then you have to add amine. For example, in this case, it will become methylamine. The next example for you is CH3, CH2, NH2. Okay, the IUPAC name will be ethanamine because 2 carbons are there, and common name will be what? We will treat this thing as a substituent and we will write ethylamine. Similarly, you have, it's your homework that you have to write C3, you have to write IUPAC as well as common names for the following structure. The structures are okay. So for these two structures you have to write the IUPAC as well as common name, and you have to also draw its skeletal structure. So now one more class work question for you, in fact I should say, is this. So the very first thing is this: you have to write the alkane, so it is propane, and at the second position amine is there, so I will write it as propane 2 amine. Okay, tell me the name of this compound. It is cyclo compound, right? So how will I write the name? I will write cyclohexane amine. Okay, now let's discuss a case of 2NH2. So these are your 2NH2. Now how will you name? So first of all, this will be my parent chain. How many carbons are there? 1, 2, 3, 4, 5 and 6 carbons are there. So it is hexa. Okay, in fact I have to write hexane, and at the first and second position 2 amines are there, so I will write diamine. Now you know there is no vowel problem because there is no vowel repetition, so I will write hexane 1, 2 diamine. That will be my name. Now let's discuss the case of amines having benzene ring. So IUPAC nomenclature retains the common name aniline for what I have already told you in special structures, that is benzene on which NH2 has been attached. So its IUPAC as well as common name is what? It's aniline. Right? It is the even simplest aromatic amine. Now, as we know that in common naming, what I am saying to you, that in common naming, what we do alpha, beta, gamma, right? Here, In IUPAC of aniline, we can write the substituent with ortho, meta and para. O is your ortho, M is your meta and P is your para. And this terminology to understand is ultra important for you. Why? Because most of the questions come in exams like IIT, JEE and NEET, in which orders are asked, like solubility order, hydrogen bonding order or some solubility order in the sequence of ortho, meta and para. Okay, so let's see what is this ortho, meta and para. So in general skeleton, if I tell you, this is what? This is your aniline. Okay, if something is attached here, means just adjacent to NH2, either here or here, both are same things, so it will be ortho. If something is attached here or here, it's same thing, it will be your meta. If something has been attached here, it is what? It is your para, right? Now let's understand this with the help of diagrams also. Suppose I attach NO2 here, hypothetically. Okay, so what it will be called? This position is known as ortho, right? So I will write it as ortho, nitro, NO2 group is known as nitro and this whole thing is known with aniline. So I will write this thing. Okay, next example is, this is NH2, right? Suppose here I added NO2, so what is this position? This is ortho, meta. Okay, so I can write it as meta. NH2, NO2 is nitro, so nitro and then aniline. Fine. One more example if I give you. This is your NH2 and this is your NO2. Now what will be the name? At para position nitro has been attached, so it will be known as para nitro aniline. Okay, am I clear? Some more examples for you. Here NH2 has been attached and here CH3. Suppose I want to write the systemic name. So in systemic name, I will write it as 1, 2 and 3. So how will I write? I will write 3-methyl aniline. Okay, this I will write. But this thing is also known as meta-toluidine. That is its popular name. Okay. Unsymmetrical secondary and tertiary amines are commonly named as N-substituted primary amines. So what I just said, I said about N-substituted primary amines. Means substitution has been done. Hydrogen has been removed and something new has been attached. Okay, this is N-substituted primary amine. So what is the thing that unsymmetrical secondary and tertiary amines are known as N-substituted primary amines? This we have discussed in the degrees also, that how substitution occurs and why it is unsymmetrical. So you already know this point. Here we need to practice the questions only. So the very first question is this. Now you tell me. So up to here, this structure is what? It is aniline. Okay. And if I ask you the location of this substituent, that is methyl. So what is its location? It is located on the N, right? So I can write it as N-methyl aniline. That will be the name of our compound. The next example for you is okay. What will be the name of this compound? Now you know that there are two substituents at the nitro. So it will be N, N dimethyl. This is cyclo group, so I can write it as cyclopentane amine. Okay. Now one more example for you. It is CH3, it is NH. Okay, here CH, here CH3, here CH3. Now you tell me that what will be the principal chain? The principal chain will be the chain having maximum numbers of carbon. So this will be my principal carbon chain, right? This will be
crowded classes, these gaps go unnoticed. With one-to-one mentoring, chemistry becomes logical and real improvement begins.